It's very unstable. It's about to explode.
No, give me the timescale for that.
The thing is, it could be tomorrow. It could be during this broadcast, and it would shine like a second sun in the sky.
For centuries, Betelgeuse has fascinated astronomers and skywatchers alike. This massive red supergiant, sitting prominently in the constellation Orion, has been a cosmic icon, glowing brightly as one of the most easily recognizable stars in our night sky. But recently, Betelgeuse has made headlines once again, and this time the story is even more dramatic than before. The James Webb Space Telescope, humanity's most powerful eye in the sky, has just detected something extraordinary, a sudden 250% increase in the brightness of Betelgeuse. This shocking surge in luminosity has sent ripples through the scientific community and sparked widespread speculation about what could possibly be happening to this colossal star. To understand why this event is so astonishing, we first need to step back and explore the nature of Betelgeuse itself. Located around 640 light-years away, Betelgeuse is classified as a red supergiant. These stars represent one of the final stages of stellar evolution for massive stars, far more massive than our Sun. In fact, Betelgeuse is about 20 times the Sun's mass and nearly 1,000 times its size. If placed at the center of our solar system, Betelgeuse's outer layers would extend beyond the orbit of Jupiter. That's how truly gigantic it is. Stars like Betelgeuse live fast and die young compared to stars like our Sun. While our Sun enjoys a stable lifespan of roughly 10 billion years, Betelgeuse is burning through its nuclear fuel at a much faster pace. Already in its late evolutionary stage, Betelgeuse has expanded into a red supergiant, fusing helium and heavier elements in its core. Eventually, it will meet a violent fate, exploding in a spectacular supernova that will briefly outshine an entire galaxy. The question astronomers have been asking for years is simple but profound. When will that explosion happen? In late 2019 and early 2020, Betelgeuse dimmed dramatically, leading some to speculate that the star was on the brink of going supernova. Observations revealed that the dimming wasn't a prelude to an imminent explosion, but rather the result of a massive dust cloud ejected from its outer layers, partially blocking its light as seen from Earth. That event demonstrated just how unstable Betelgeuse really is, and it reminded us that we are witnessing a star in its final, chaotic chapters. Now, with the James Webb Space Telescope detecting a sudden 250% increase in brightness, the narrative has become even more intriguing. The James Webb Telescope, launched in December 2021, is equipped with cutting-edge instruments designed to capture light across infrared wavelengths. This allows it to peer through cosmic dust and unveil details about stars and galaxies that were previously hidden from view. When it turned its gaze toward Betelgeuse, astronomers expected to see variations in brightness, since red supergiants are known to pulsate and change luminosity over time. But no one anticipated such a dramatic surge. A 250% increase is not a minor fluctuation. It is a colossal transformation that demands an explanation. One possibility is that this brightness surge is linked to Betelgeuse's ongoing pulsations. Red supergiants undergo periodic expansions and contractions as their outer layers shift in response to the processes occurring deep within their cores. These pulsations can lead to fluctuations in brightness that are visible even across hundreds of light years. But a jump of this magnitude suggests something more intense is happening beneath the surface. It could mean that Betelgeuse is undergoing a fresh phase of instability, perhaps tied to convection currents carrying hot plasma outward in massive, turbulent waves. Another explanation could involve a renewed ejection of stellar material. When stars like Betelgeuse expel matter into space, that material can form dust and gas clouds that either obscure the star's light or reflect it in unexpected ways. The sudden brightening could be the result of changes in these clouds, where previously obscured light is now reaching us unobstructed, or perhaps where shockwaves from fresh eruptions have caused surrounding material to glow more intensely. If true, this would mean we are witnessing Betelgeuse's atmosphere in the throes of violent upheaval. Of course, the most tantalizing possibility is that Betelgeuse is entering the final stages before its inevitable collapse. When a massive star like this runs out of nuclear fuel in its core, gravity eventually overwhelms the outward pressure, leading to a core collapse supernova. If Betelgeuse were about to explode, the sudden brightening might be an early warning sign. However, most astronomers caution against jumping to this conclusion too quickly. Predicting the exact timing of a supernova is extremely difficult. While Betelgeuse is certainly destined for such an end, it could still be tens of thousands of years away, or it could happen tomorrow. The truth is, we simply don't know. What makes this sudden brightening particularly exciting is the unprecedented ability of the James Webb Space Telescope to monitor it in exquisite detail. Unlike earlier observatories, JWST's infrared vision allows it to peer directly into the turbulent outer layers of Betelgeuse, where hot gases, shock waves, and massive convective plumes are shaping its fate. Scientists are now analyzing the data to determine whether the surge in brightness is localized, coming from certain regions of the star's surface, or whether it is a global change across the entire stellar atmosphere. If the brightening is uneven, it may point to colossal hotspots rising from deep within the star, far larger than anything seen on our Sun. To appreciate just how extreme Betelgeuse really is, consider this. Its surface is not smooth or uniform like a glowing sphere. Instead, it is a dynamic, chaotic environment where convection cells, each the size of planets, churn and shift constantly. These giant upwellings of plasma rise, cool, and fall back inward, creating fluctuations in both temperature and brightness. The 250% surge could indicate that one of these convective events reached extraordinary intensity, momentarily unleashing far more energy than usual. Imagine storms larger than Earth itself erupting across a star so vast that even these cosmic tempests are only surface ripples compared to its true scale. There's also the question of how Betelgeuse interacts with its surroundings. Over the millennia, the star has been shedding material into space, forming a vast envelope of gas and dust that envelopes the system. JWST's instruments are capable of detecting the composition of this material, revealing elements such as carbon, oxygen, and heavier atoms forged in the star's interior. These observations are crucial, because when Betelgeuse eventually explodes, the debris it hurls into space will enrich the interstellar medium, seeding future generations of stars and planets. In other words, what we are witnessing today is not just the possible prelude to a cosmic cataclysm, but also the process by which the building blocks of life are distributed throughout the galaxy. Some scientists believe the brightness surge could be tied to a structural change in Betelgeuse's core. As the star fuses progressively heavier elements, layers of nuclear reactions build up like the layers of an onion. Hydrogen fuses into helium, helium into carbon, and so on, until iron eventually forms in the core. Each of these transitions releases different amounts of energy, and sometimes the balance between inward gravitational collapse and outward pressure can shift dramatically. If Betelgeuse is undergoing one of these transitions, the extra energy could manifest as an outward burst of luminosity, giving us a rare window into the interior life of a dying star. But the brightening also carries a more profound implication. If Betelgeuse is indeed preparing for its final collapse, its eventual supernova would be one of the most spectacular astronomical events in human history. At its peak, the explosion would likely shine as brightly as a full moon in Earth's night sky, visible even during the daytime for weeks. Civilizations around the world would witness it without the need for telescopes, just as ancient cultures recorded similar stellar outbursts centuries ago. For astronomers, it would be a once-in-a-lifetime opportunity to study a nearby supernova in unprecedented detail, helping refine models of stellar death and cosmic recycling. However, it's important to remember that cosmic timescales don't align neatly with human curiosity. The brightening we see now could be part of a natural cycle that Betelgeuse has undergone many times before, with no immediate link to its eventual explosion. The star is known to vary in brightness over periods ranging from hundreds to thousands of days, driven by pulsations and atmospheric dynamics. This 250% increase may simply be an exaggerated form of its usual variability, though one amplified enough to capture global attention. Still, even if it isn't the final warning sign, it remains a crucial data point in understanding how stars behave at the edge of their lives. Adding to the intrigue is the fact that different wavelengths of light may tell different stories. In visible light, the star appears dramatically brighter, but in infrared, the changes might look subtler or reveal additional details about dust clouds surrounding it. Webb's instruments can dissect this light into spectra, effectively breaking down the fingerprints of the elements present in and around the star. By comparing how these spectral lines change during the brightening, astronomers can track movements of gas, detect shock waves, and even estimate the temperature of different layers. It's like performing a medical scan of a dying star, layer by layer, moment by moment. The implications of this discovery extend beyond Betelgeuse itself. Red supergiants across the universe follow similar evolutionary paths, and by studying Betelgeuse's behavior, astronomers gain insights into how other stars will live and die. Understanding these processes is key to building a complete picture of the cosmos, since supernovae play such a critical role in shaping galaxies. They forge the heavy elements essential for planets, oceans, atmospheres, and even biology. Without them, life as we know it would not exist. Betelgeuse's brightening, then, is not just a local curiosity, it's part of a much larger cosmic story. One of the most remarkable aspects of Betelgeuse's story is how it connects us to the wider history of human curiosity. Ancient civilizations tracked the star, weaving it into their myths and legends. The ancient Egyptians noticed its position in Orion, the Greeks saw it as part of the mighty hunter, and cultures across the globe gave it names and meanings tied to harvests, seasons, and even omens. Now, thousands of years later, we study it with the most advanced telescope ever built, revealing secrets that our ancestors could never have imagined. This continuity between past and present shows how Betelgeuse has always been more than just a point of light. It has been a companion to humanity's journey of discovery. The sudden 250% increase in brightness reminds us that stars are not static. They live, they change, and they die in ways that affect everything around them. For us, living so close to Betelgeuse in astronomical terms, it is a front-row seat to the end of a stellar giant. Though 640 light-years may sound distant, it's relatively close in the cosmic scale. That proximity is what makes Betelgeuse's every shift so important. Each fluctuation in its light is a clue to its internal drama, a window into processes that will eventually end in one of the most awe-inspiring events visible to the human race. If Betelgeuse were to explode within our lifetime, the impact would be spectacular but not dangerous. Astronomers assure us that even a supernova this close would not threaten Earth. The star is far enough away that harmful radiation will disperse before reaching us, leaving only the visual wonder of a star's final act. The night sky would be transformed for weeks, and our descendants would remember it for generations as the great supernova of Betelgeuse. For science, it would be the most well-documented stellar explosion in history, reshaping theories of how massive stars live and die. The work of the James Webb Space Telescope is crucial in this moment. Its ability to capture faint details in the infrared spectrum has given us a clearer picture of Betelgeuse than ever before. By studying how the star's brightness has surged, how its outer layers are shifting, and how dust clouds are forming and dispersing, scientists are piecing together the timeline of its evolution. Webb is not just watching a bright star, it is unraveling the final pages of a stellar epic. Every photon it captures brings us closer to understanding not only Betelgeuse, but also the ultimate fate of massive stars across the cosmos. In the end, whether this brightness surge marks the beginning of the end or simply another chapter in Betelgeuse's turbulent life, it highlights the profound truth that we are witnessing something extraordinary. A star hundreds of times larger than our Sun, nearing the end of its cosmic story, is putting on a show that echoes across space and time. And thanks to the James Webb Space Telescope, we are not just passive observers. We are active participants in decoding the mystery, turning raw light into knowledge. When you look up at Orion in the night sky and spot the bright, reddish point of Betelgeuse, remember that you are gazing at a dying giant, a celestial titan in its final acts. Its light, now magnified 250%, has traveled hundreds of years to reach us, carrying the story of instability, turbulence, and impending transformation. Whether the supernova happens tomorrow, in 100 years, or in 100,000 years, Betelgeuse is reminding us that even the mightiest stars are mortal. And when it finally does explode, it will be both an ending and a beginning, the end of a star's life, and the beginning of countless new stories seeded by its remnants across the galaxy. For now, all we can do is watch, study, and wonder. The James Webb Telescope has given us front-row seats to one of the greatest cosmic dramas unfolding in our galactic neighborhood. Betelgeuse is brighter than ever, and the universe is reminding us once again that it is alive with change, surprise, and awe. And in that brightness, we glimpse not just the fate of a star, but the story of how everything, including us, comes from the death and rebirth of stars.